Yes, one thing that you remember from yesterday's class. Just one thing. Desire?
Okay. Um, Basically, you talked about the different, we talked about validating scope, what it entails. And I remember you talking about also the breakdown, various breakdown structures.
Okay.
Yes, and there you discussed organizational breakdown, what it entails, risk breakdown, bill of materials, as well as the resources breakdown. So I remember that. That's one of the things I remember.
Okay. But that's day before yesterday.
Was it day before yesterday? Oh,
Yes.
okay. Yesterday, I remember we talked about scope, the different the concepts. I know that you talked about the key concepts, which are the elements of a schedule.
Okay.
I
Yeah.
remember that one. Yes,
Yeah.
the elements of schedule, where you
Okay.
discussed the dependencies from the beginning. Actually, you talked about the
Mhm.
activities, identifying the activities, and planning. We plan dates.
Okay.
Then we also, what other things now? Okay, we do durations, then we do resources, then dependencies, and some are interdependent on one another. I remember you
Awesome.
talking about that. Yes, and
Awesome.
constraint.
Great,
Yes.
great, great. The elements that make up a schedule are activities, plan dates, duration, resources, constraints, and dependencies. Thank you so much, Fisaya, for that. Let's hear from Sean. Sean, one thing
Um,
remember from
yeah,
this.
I remember we talked about dependencies, and then you talked about how mandatory, we talked about external, internal, and discretionary. Then we also talked about is it predecessors? First of all, you talked about those diagrams. You talked about precedence,
Precedent diagram.
diagramming,
Yes.
diagram, uh-huh. And then
Diagramming
you talked,
method.
yes, and then you talked about that showing how the process of scheduling and all will go. And you also talked about the arrow method that you said is outdated.
Yes.
Then you talked about the different, you talked about the predecessors, right? Where you
Yes.
talked about that that's a difference between the two of them. And that's where you now explained the different types, the start to finish, finish to finish, um, finish to finish, finish to start, and one more.
Finish to
Uh,
start, start to finish
finish,
to finish, and start
finish,
to
and
start.
start to start. Exactly, start to start. And then you broke that down for us. So yeah, I remember this.
Awesome. Awesome. That's great. That's a great job, you guys. Yes. So we're going to continue from there. And I think that was the last thing we talked about, the predecessor types. It was the last thing we talked about. So now we're going to talk about lag and lead. So what is a lag? A lag is a delay between activities. So if you finish an activity and you cannot immediately start the other activity because you have to wait, then that waiting period is called a lag. That waiting period is called a lag, right? So you finish the task, you cannot immediately start the next task because of a delay. The delay is called a lag, right? And it doesn't matter what causes the delay. That delay is called a lag, okay? Then we have what we call a lead. We have what we call a lead. So what is a lead? A lead is an accelerant. In other words, a lead helps us to speed things up. And a one-day lead means that activity B or task B starts one day before A finishes. That's why it's like going halfway into A. So that means when task A finishes one day, task B will start and do share one day with A and then end. So A lead helps us to speed up or accelerate two tasks, right? Helps us to speed up and accelerate two tasks. So let's move on and look at how activities can be numbered based on their start duration and finish dates. In order to understand this diagram, we have to look at the legend below. So the activity on the top left is the early start. The number in the middle is the duration of the task, and the number on the top right is the early finish. So let's look at the first diagram. The first diagram is the standard path with no lead or lag. The standard path with no lead or lag. So what does that mean? It means that there's no lag. Excuse me. Nor is there any lead. It's just, finish the start, finish the start, finish the start. No lag, no lead. So let's look at the first activity. Activity A starts on the first day. It's going to take 4 days, and then you can count 1, 2, 3, 4. So it's going to end in the evening of the 4th day. Now, activity B, which comes next, which is a finish. We finish A in the evening. We start B in the morning of the 5th day, and then you count 3 days. 5th, 6th, 7th is 3 days. Now, you wonder why I'm counting with my fingers, right? I said 5th, 6th, 7th is 3 days. Why am I not saying 5 plus 3? Because if you do 5 plus 3, you're going to get 4 days. Because 5, 6, 7, 8, if they're all old days, is actually 4 days. You can look at it. So if I said 5 plus 3, so activity A will start on B, will start on the 5th, end on the 8th. That is actually 4 days. If you're counting the 5th day, if the 5th day is inclusive, which it is, because we're starting on the morning of the 5th, so the 5th is a whole day on its own. 6th is a whole day on its own. 7th, so B is finishing in the evening of the 7th, not in the morning, evening of 7th. So we have 3 full days. So you don't do 5 plus 3. In fact, there's a formula for this, but we'll talk about it later. But for now, use your fingers or write out the numbers. So 5, 6, 7, so you can know it's actually 3 days. So don't say, oh, you have a 2-day task. Some people make this mistake up to now. So let's say that, what's this date? Okay.
16th of December.
Oh. Okay.
Oh, it's 17 on your end.
No, it's 17 on your end. On my own.
Oh, sorry, 17th.
18th on your hand.
It's 18th on your end.
Our own
Sorry.
is okay.
Okay. So imagine you're starting a task tomorrow, 18th, and it's going to take 2 days. When should you finish that task? You are starting a task tomorrow, 18th, and it's going to take 2 days. When will that task end? Yes. Someone help me.
19.
Thank you. Well, you know what some people would do? 18 plus 2, 20th. And that's 3 days. They've added 1 extra day unknowingly. So you don't add activities like that. You have to think about what you are doing before. That's why the numbers here look a bit strange, but they're not strange. So activity B will finish on the 7th evening. Notice I'm stressing when. Evening of the 7th. which means we can't start any other thing on the 7th, is in the evening. So activity C will start in the morning of the 8th day, and it takes 5 days. So you count 8, 9, 10, 11, 12, and that it means that C will finish in the evening of the 12th day. Now, there are two ways to do this, and automatically, I'm showing you one way that you should stick with. The reason why I'm saying this is because some people, there's another method where you start with 0. So instead of starting with 0, instead of starting with 1, you can say you're starting with day 0, and then you now do 0 plus 4, which is 4, right? And it's a little different, but I like the concept of I'm starting on day 1. So if you read any textbook or you're watching any video on how to number your activities, especially when we start talking about a topic we're going to do today on the critical path method, these 1 and 0 are different ways of numbering your task. Well, guess what? I learned 1. So I teach 1. Doesn't mean that you might not come across and say, these people are using 0. Yeah, that's why I'm telling you that there's another method now. And I think I prefer the 1, right? So let's look at the standard path. So this path has no lead or lag, but in the second path is the same series of activities, but this time we've introduced a 5-day lag. So activity A will start on the 1st, finish in the evening of the 4th day. So when does the lag start? The lag will start in the morning of the 5th. That's the 1st day. 6th, that's the 2nd day. 7th, that's the 3rd day. 8th, that's the 4th day. And it will now finish in the evening of the 9th. That's a 5-day lag. No work will be done on these dates. So activity B will now start in the morning of the 10th. It takes 3 days, 10, 11, 12. Finish in the evening of the 12th. C starts in the morning of the 13th and continues to the 17th. Now, let's look at the last series of activities, but now we're introducing a 2-day lead into the standard path. Now, activity A is going to finish on the 4th, but 2-day lead means that activity B starts 2 days before A finishes. And 2 days before A finishes means activity B will start on the 3rd. 2 days before A finishes means activity B will start on the 3rd, right? Now, 3 days, 3rd, 4th, 5th. Finish in the evening of the 5th, and it's going to start in the morning of the 6th, and we count 5 days, 6, 7, 8, 9, 10. And that's 10th, finishing in the evening of the 10th, okay? So let's continue and talk about estimating methods. And the reason we're talking about estimating methods is because the next process has to do with how we actually estimate the duration of activities. That's what we're going to talk about next. The next method talks about how we're going to start estimating activities, right? So there are 4 estimating methods. So the first one is called analogous estimates. Now, analogous estimates are also known as or sometimes called top-down estimates. And There are estimates you derive when you compare to a previous project. So when you compare to a previous project, we call it analogous. Now, what is the meaning of analogous? Now, analogous is from the word analogy, and analogy is more or less when you want to compare two things. Analogous itself means to compare, right? Yeah, so analogous is whenever you generate an estimate when you compare to something you've done in the past. So I'm going to ask you guys a question. So Fisayo, how long does it take you to get to work on the average?
I think 30 minutes.
Okay, great, 30 minutes. So how long does it take you to get to work?
About 45 minutes.
45 minutes. My question to you guys is, how did you get that estimate? How did you generate the
How?
estimate? Yes, how?
Google Maps.
No, I'm talking
Google.
about not using Google Map. I'm talking about from experience. How did you generate those estimates?
From day-to-day movements over
Yes,
time.
you do it every day. So because you do it every day, the last time you went to work, that you timed yourself, you notice you left at maybe 7:30 a.m. and you got to work 8 o'clock, right? Or let's say for sure, you left 7:15 a.m. and you always leave 7:15 a.m. and you always get to work 8 a.m. So if I ask you now, how long does it take you to get to work? It's because you've done it so many times. From your experience, you are giving me an analogous estimate. Do you get what I'm saying? Because you've done it several times. And let me give you another example. So let's say you are painting a house and it took you 2 weeks to paint a house. And then you see a house similar to yours, right? And someone is asking you, how long do you think it would take to paint this house, not your house, this house that resembles yours? You're going to tell them 2 weeks. Why? Because you've done it before. That is analogous estimate, right? And let me give you my last example. So, sorry, it's going to be a Nigerian example, and I'm giving this example for one reason. You see, when I'm talking about the next estimating method. So if someone asks me, how long does it take to travel from Lagos to Ibadan? Based on my experience in the past, I'll probably say it's 1.5 hours, right? 1.5 hours. I'll probably say 1.5 hours. And this will also be known as analogous estimate because it's from what I did before. Now, bottom-up estimate is where what you want to estimate, you first of all break into smaller pieces and then you estimate. So it's a different estimating method from analogous because analogous is comparing to what you've done before or a previous project. Bottom up says, look, what you want to estimate, first of all, break it into smaller pieces. And I'll also ask you to do the same exercise with your original estimate. But let me do Lagos Ibadan using bottom-up estimating. So for Lagos to Ibadan, if I'm using bottom-up estimating, I'm going to break the journey into different parts. So I'll say from let's say Ikeja, Lagos to Mowe. I'll probably give it 15 minutes. Right. I'll give it. I'll probably give it 15 minutes. 10 minutes. Then move way to help you guys not lost here to RCCG, right? And I'll probably give it 10 minutes. Then from RCCG to Shagamu interchange, I'll probably give it 20 minutes, right? Probably give it 20 minutes. Then from Shagamu interchange to Ogere, I'll probably give it, which is the former middle toll gate, I'll probably give it 5 minutes. Then from Ogere to Sadhguru Maharaji, I'll probably give this another 30 minutes, 35 minutes. Let me leave it at, and Sadhguru Maharaji to Ibadan. I'll probably give it 5 minutes. It's even a bit less. So let's add up 20, 20, 10. So I have 30, 50 minutes, 30 minutes. I have 1 hour, 20 minutes. So initially I used Analogous and I got 1.5 hours. Bottom up, I'm getting 1 hour, 20 minutes because I'm using a different method. Now, in your own scenarios, a bottom-up estimate is to break down your route to work. Maybe if you can get the the number of roads or streets you take to work, and then you estimate, right? That's if you drive or walk, right? So you need to break down your journey, estimate each section of your journey, and sum it up. That's bottom up. It's different from Analogous. Parametric, using the same example, parametric means you use a parameter to generate the estimate. So here, I'm going to use the average speed of the car. So let's say I'm going at 100 kilometers per hour. What is this? This is the parameter I'm using. And the distance is 150 kilometers, right? Then it means my it's going to take me 1.5 hours, right? So if you have a parameter, then you use parametric estimating. Like speed is a parameter. Or let me give you another one. A tiler, someone who lays tiles, a tiler takes 5 square meters. A tiler can lay 5 square meters, 5 square meters of tiles in 2 hours. Now, I want to estimate how long it will take him to lay 100 square meters of tiles. And of course, this becomes a mathematical equation. So parametric estimate usually leads to computation or calculations, as the case may be. And it's a simple cross multiplication where I multiply 100 square meters times 2 hours divided by 5 square meters. And what you get will be 40 hours, right? 40 hours. And that will be the answer is going to be 40 square meters. 40 hours. So I'm using parametric estimate. So you can see I'm still talking about, in the case of Lagos Ibadan, I've used analogous, I've used bottom up, I've used parametric, which means for a single task, you can use multiple techniques, estimating methods that are available, right? And then the last one is called Monte Carlo, computerized or Monte Carlo estimates. And this is where the individual items are estimated and summed up for total cost. So in Monte Carlo, we estimate each task and then we sum them up for total cost. No, sorry. Monte Carlo is a software, right, that generates estimates based on probability, which means you're going to, so how it works is you're going to come up with an estimate and the probability of you achieving that estimate. So let's say I can ask you, right? I can ask you, what's the probability of you getting to work in 45 minutes, right? And if you could generate that probability for me, Monte Carlo will simulate to actually get, based on your probability and the estimate you've given, Monte Carlo will simulate that estimate up to 100%. It will simulate that estimate up to 100%. And that is, so it's a software that uses probability to generate estimate. Now, since we have 4 estimating methods, which one do we use? That brings us to the next thing, the pros and cons of each estimating method. The pros and cons of each estimating method. So when it comes to analogous estimate, we have the advantage and disadvantage, and this usually guides which one to choose based on the scenario. And what this also means is that you can sample a number of estimating methods and look at the one that looks more realistic. But you have to also pay attention to the advantages and disadvantages so that you know which method you use for which situation. So let's look at the first method, analogous. If you notice, analogous is very fast. When I asked you how long it takes you to get to work, you guys didn't spend 2 minutes. They even spend up to a minute. In fact, probably like 10 seconds, you gave me the answer. But, so it's fast. It's fast, right? But the challenge with analogous, it's not a detailed estimate. You can't give me the details of what makes up the 45 minutes. You can't tell me how the journey to your workplace is 30 minutes. You didn't give me that information. You didn't give me the details of what generates the estimate. You just gave me a top-down estimate, a general estimate from past experience. Now, let me also talk about this word, top-down. Top-down usually signifies the kind of estimate top management gives when it comes to projects. They will just compare the last time we did this project, how much did it cost us? Or how long did it take us? And then they just generalize and say this project should take us this amount of time. That's a top-down estimate, right? So it's usually used by management. So you can now see the use case in terms of application. It's usually used by management because nobody has that time to now do detailed estimation, right? So it's a top-down, it's fast, but it's not detailed enough to look at the component. Now, let's look at bottom-up. Now, Fisayo and Sean, I want you to tell me your route to work. Yeah, Fisayo, let's start with you. What's your route to work? Or, yes, what's your route?
Okay, from my hand here to Kingsway, well, there's a place where you call Kingsway. There's like let's say about 7 minutes. Just those are the should I call them milestones or areas where?
Yeah.
Yeah, okay.
You can
So
talk about it.
Okay, so from here to Kingsway is 7 minutes. From Kingsway to Westmont, that's like around 13 minutes.
13 minutes, okay.
Then from Westmont to my office, that's like 10 minutes.
Okay, so that's what makes up the 30 minutes.
Yes.
All right, fantastic. All right, let's ask Sean to break our own journey down using bottom-up.
So using bottom-up, I drive from my house to join McLeod. That would take me about 5 minutes.
Okay.
And then from McLeod, I drive down to join Canyon Meadows. So that would take me another 7 minutes.
Okay.
And then from Canyon Meadows to Deerfoot, I have to join Deerfoot, take me another 5 minutes. And then from Deerfoot, I drive all the way down to work. Now, to get to work, I still have to make some few turns, but those ones are like 1 minute. But from once I join Deerfoot, all the way straight down to my office. Now takes the remaining.
So from Deerwood, right? Is it Deerwood or Deerfoot?
Deerfoot.
Okay.
Yeah.
Deerfoot. I wonder who named the road.
Deerfoot Trail, because you have deers, so it's always put on those roads that the deer can come off on those major trails. Yeah.
This was what I was thinking you were saying. Deerfoot.
No.
Okay.
Deer animal.
Deer animal foot. Okay.
Yeah.
All right.
Yeah.
So that means that from what we've calculated is 17 minutes when you get to Deerfoot. Then Deerfoot to your office takes the remaining 45 minutes. That's the remaining
28 minutes. Yes.
All right. Now, based on when you were doing bottom-up estimate, compared to analogous, which one was faster?
Analogous is faster.
Analogous is clearly faster because when you're doing bottom-up estimate, or Sean, do you agree with that, or you disagree?
Yes, yeah, it's faster because that one I'm not breaking it down. I'm not
You're
trying
not
to
breaking it down. Yes. And now we also see what a detailed estimate is, because in bottom-up, you're giving me details of your journey. You are estimating it. So it's a more detailed estimate than analogous. And that's what I wanted to bring out from your breakdown of your journey. It's a more detailed estimate when you use a bottom-up estimate. Now, I want to show you something that is also interesting. Now, you know that analogous is sometimes called top-down, right?
Yeah.
Now, if it's called top-down, look at the word top and bottom. Look at the word down and up. They are exactly opposites of each other. And that means, since they are opposites, then it means that the advantage of top-down or analogous is going to be the disadvantage of bottom-up. And the disadvantage of top-down or analogous is the advantage. So let's look at it. So what I'm showing you is that there's a relationship between the first two that we talked about. So, like we saw, bottom up is a detailed and accurate, more detailed and accurate method than analogous. Analogous just gives us a general estimate, right? While bottom up is detailed. Now, the disadvantage of the advantage of analogous, which is fast, which we also saw, is a disadvantage of bottom up. It takes time to generate. It takes time because we have to think through all the different aspects of what we want to estimate, break them down, and then estimate. So it takes time. Now, another disadvantage of bottom up is that because we are breaking the estimates and summing them up, your team members can pad the estimates to compensate for known or risk, which means, and this is actually a good way to estimate, you factor in risk. It's good. But the challenge is when you're doing bottom-up estimating, remember, you're going to estimate each task. So take, for example, task A should naturally take 4 days, normally take 4 days. But we might say for the sake of risk or unknowns, or, we just want to put in a buffer just in case of any risk, right? We make it 6 days, right? Now, so that means ideally task A should take 4 days, but we've just given a buffer of 6 days. Now, this is the same thing. Maybe you're at work and maybe your manager asks for you to do something, a task, and he's saying that, can you do it within 2 days? And then you ask for an extra day. You're asking for an extra day just to put a buffer in case of risk and say, okay, 3 days, okay, that's fine. But imagine that we have a project where there are 100 tasks and your team members are systematically adding 2 days per task. What happens to your project is that systematically we've added 200 days into the project. And 200 days without weekends, that means 5 days per week, becomes 40 weeks. 40 weeks is almost the equivalent of 10 months. So you can imagine that just by using bottom-up estimating, which is very detailed, we can systematically add 10 months to a project's timeline because of the method of estimating that we're using. So this is usually the challenge when you're doing detailed estimating and you're factoring, adding some extra duration to compensate for unknowns, right? And it's not a bad thing, but you can see the cumulative effect if we keep doing that for every task. It can significantly add extra timeline. But guess what? This is not the worst scenarios, right? It's bad, but the conversation has not ended because there are 2 other things that contribute to this phenomenon. And one of them is called Parkinson's law, right? Parkinson's law. The second one is called Student's syndrome, right? Student syndrome and Parkinson's law. What is Parkinson's law? Parkinson's law states that people will consume the time you give them. It's a law. Well, yes, it's a law. They call it a law. So that means that these 6 days that you've given your team, they are going to use it up. That's what Parkinson's law states. The time you give someone, right, is they're going to use that time up. So if your manager gives you, it's meant to be 2 days, and you ask for 1 extra day, 3 days, they're going to consume that whole 3 days up. That's what Parkinson's law states. Student syndrome actually tells you how it's going to happen. And at one point in your life, you've actually been a student. So when I explain student syndrome, it's not going to sound strange. So let me explain it. So imagine that you are doing a lecture, right, in university, and that lecture is the last lecture for the week. I'm talking about Friday, your last lecture on Friday. No other lecture after that one. So what in the mind of students is, how am I going to spend this weekend? Or thank God that I have a break, I can rest my mind. So imagine in that last lecture, lecturer, doctor, professor, whoever is taking the course says, I'm giving you an assignment and I want you to submit in 2 weeks' time. So what will happen is that lecture is over, everybody is in the weekend mood already. We're not thinking about any assignment, right? And what will now happen in 2 weeks' time is that the lecturer will ask for his assignment. What do students do? So let me tell you what they sometimes do. You send your class rep as your representative, the job that you gave your class rep, to go and plead, or you follow class rep to lecturers to beg lecturer that she give you, that you drop it the next morning. So what am I trying to say? Students procrastinate. Now, so let's look at how they'll probably do this 4-day task. So on day one, when they start the task A, in the mind of the person doing the work, the person doing the work knows they can do it in 4 days. So in day one, they start dragging their feet. Something they can finish in 1 hour, they'll take 4 hours to finish. So day one, we're just warming up to the work. Day two, there's a carryover of what happened in day one. So within 2 days, very little work has been done. Now we get to day three. Day three is exactly 4 days. That's when seriousness comes in. And then everybody's serious now, because now I know I only have 4 days left, right? So I'm working seriously. In fact, if you look at the person from day 3 to day 6, you think that's how they'll be working from day 1. Now, just imagine if something now happens. Now, the reason we added 2 days was to take care of contingencies, things that can happen to add extra time. Now, if that thing that we felt might happen now happens within day 3 to 6, guess what? The task will now end in 8 days. Right? And this is what we call task inflation, which means we've inflated the duration by 4 days. Now, the next time they're doing a similar task and you ask them how long it should take, they'll probably be telling you 8 days. But that's not what happened. Right? So, can you see how student syndrome and Parkinson's law works together? And I have a question for us. What can we do about this? because what this means is that, so I want you to go to your AI tool and type how, oh, sorry about that. I want you to type in a very simple way, how can you deal with Parkinson's law? So let's do a little bit on task. In a very simple way, how can you deal with Parkinson's law when you are estimating when on task? So let's see what it gives us. Let's do fastest fingers. Anybody? Anybody? Okay, so that it doesn't take our time.
It says set clear goals and deadlines.
Okay.
Break tasks into smaller chunks.
Okay.
Prioritize tasks. Is it in line?
I've
I
never
don't.
researched it.
Oh, okay. It says
So,
set clear goals and deadlines. In
mhm.
other words, define specific objectives and timelines. Then the next bullet point says break tasks into smaller chunks, make tasks more manageable and estimable.
Okay.
Then the bullet point says use time boxing. That is, allocate fixed time slots for tasks. The other one says, the next point says prioritize tasks. Then another one, use estimation techniques. And the last one, review and adjust.
Review and adjust. Okay. So that's one way. Sean, anything from your end?
Yes, let me read it out. So it says set short artificial deadlines. Like, don't use the real deadline for daily work.
Ah,
And that's where it talks about breaking a task into small chunks, give each chunk a tight deadline, and treat these as non-negotiable. Then it says to time box the work. Decide how long you will work, not how much you will finish. So if you need to use a timer, and then you do continue like that. When it's time to stop, you stop and move to the next one, even if it's not perfect. Then it says define done before you start. Ambiguity fuels expansion. So find exactly what done means before you even start. And then limit scope on purpose. Consciously remove nice to haves. Decide what you will not do and postpone any enhancements on a separate list. And it says to create urgency, even if it is artificial. It will help to compress efforts and then separate creation from perfection. So perfectionism is Parkinson's law in disguise. So trying to make it perfect, make it slower, just keep. And then it says track how long tasks actually take. I was going to say that is it possible to kind of merge and look at ways bottom up, like track how long each task will actually take. So that way to reduce over allocation.
yes.
And then use a hard stop. Decide in advance at so time we're going to stop and submit to force you to prioritize what you need to do.
These are
Yeah, those are
actually
things.
very, very nice. What do you guys think? Very nice.
Yeah.
Yes. Yeah. Yeah. So
I agree.
so if you're managing a team, you can try it out. And
Yeah.
see what happens.
Yeah.
Yeah. Okay, fantastic. Fantastic. Great job, guys.
I have a question.
Yeah, please go ahead.
Sorry. So I'm seeing, looking at bottom up and the computerized. Do they do the same thing? Is the difference just the fact that one is done, I don't know, maybe manually, and the other one is done using maybe a software or something?
Yeah.
Because it seems like both of them are, you estimate and then sum up the total cost.
Okay, so when we talk about bottom up, when we talk about bottom up, we like we said, we break down what you want to
Mm-hmm.
estimate into smaller pieces, then sum up. But when we talk about Monte Carlo, we include the probability of the estimates, right? And that is what actually, that's the focus of Monte Carlo, is to generate multiple estimates of the same thing, but using different probabilities, right? That's basically the difference. So, yes, that's the basic difference. That bottom up is breaking up what you want to estimate into smaller pieces, estimate each piece, sum up. Monte Carlo is giving setting some parameters, right? Setting some parameters and using probability to generate the actual estimate you want, right? So when it comes to Monte Carlo, because you're using software, you should expect some level of accuracy. And Monte Carlo is perfect for what if analysis. That means you can play around. Okay, what if we want to generate this estimate? What's the likelihood of meeting up with this estimate? So you can play around and do what if analysis because it is software. Disadvantage of Monte Carlo is time to set up and configure the tool and cost. It's expensive. Now, Monte Carlo is not a software you can easily buy cheaply. But in the age of AI, AI has actually made some tools redundant. I'm not sure. I think AI should be able to do Monte Carlo estimates, but maybe that will be another assignment, right? Let's talk about how you get to work and ask AI that how can you generate Monte Carlo estimates? And let's see what it gives us. So it's expensive. I think the last time I was checking out the cost of Monte Carlo, it was in thousands of dollars, right? So imagine buying a tool for a project all because you want to estimate. So it's an expensive estimating tool, right? It's a software. So that's one disadvantage, right? Because you want to estimate, you're buying software that is expensive. But guess what? There's a time I was training. I've never used the tool myself, so I've never used the tool before. So it's not as if I'm an expert. But I was talking about Monte Carlo's simulation. I just noticed in this particular training, someone was nodding his head, and was even, even talking more about how to use it. So I just knew that this guy is a real McCoy, right? This guy knows what I'm talking about. This guy knows it. So during the break, I now went to talk to him, and I said, "Oh, it seems as if you use Monte Carlo." I said, "Yes, yes, yes." Now, he's a geologist for Schlumberger, and he said that they use Monte Carlo to predict the quantity of crude oil under the ground. And that's because geologists do not necessarily drill into the ground. So they have some things that indicate where crude oil could be. And when they locate such areas, there are some parameters they put into Monte Carlo that helps them to predict the quantity of crude oil so that they don't bother drilling, because drilling is expensive, until they can come up with a rough idea of how much crude oil they are dealing with. Now, oil and gas, they have money there. So if it costs them thousands of dollars to buy an estimating tool, of course, ROI in that industry is also very, very. So, it makes sense that, okay, is a tool that you can use in oil and gas to estimate for crude oil. It makes a lot of sense, right? So that's probably the only person I've met that actually uses the tool. And he uses it to estimate the quantity of crude oil in a location. All right, I think we deserve a break. Or should we just continue for the next 1 hour? Since we're enjoying the class. Should we continue for the next 1 hour? Do we need a 10-minute break? Fisayo and Shem, should we continue or take our 10-minute break?
Majority guys will do. I'm a different
Just
one.
remembering
I want to show which one you.
There's no majority, it's just me and you, Fisayo.
Unless someone else has joined that we don't know. Okay, so let's
It's
take.
just me and you.
So, Shem, what do you say? It has to be a unanimous decision.
Yeah, unanimous. We can go on if Fisayo is on board, and we can take a break or we can take 5 minutes if you want, or we can go on.
Don't worry, let's take our 10-minute break so that you guys can rest a bit. All right, we'll take our 10-minute break and come back in exactly 10 minutes time.
Okay, thank you.
Okay, see you. So we're still on the topic of estimating, but now we want to look at another estimating technique, which is called Program Evaluation Review Technique, or PERT for short. Now, PERT is an estimating technique that you use when there's uncertainty, especially when maybe something hasn't been done before and there's uncertainty and you just want to use an estimating method. That's when you use PERT. The first time PERT was used was when the US Navy wanted to build their first nuclear submarine. Now, they couldn't use analogous because nobody had built a nuclear submarine before. So you can't compare it to something. So they came up with estimates, probably generated from their experts, and it focuses on 3 variables. They come up with an optimistic, best case scenario, pessimistic, worst case scenario, and what they think realistic or most likely estimates. And that's how the estimate is generated. Another time they used PERT estimate was when they wanted to plan space travels, and nobody had gone to space then, so they had to come up with estimates using PERT estimate, and that's what they use. And of course, when it comes to space travel, you have to be very careful because the resources the astronauts are going to use is largely dependent on the calculation of the duration of the trip. So they had to get it right. So they use PERT there as well. So PERT estimate can be used anytime you have uncertainty. You have to generate 3 estimates and then use the 3 estimates to calculate your PERT. That means, just think about it. Imagine you come up with a worst case scenario, right? Of going to work. What's the pessimistic estimate? What's the worst case scenario? Optimistic, what's the best case scenario? And realistic, and then you calculate how long it takes you to get to work. That's a PERT estimate. Now, in that scenario, and you can also try and do it, come up with 3 estimates: worst case scenario, best case scenario, and realistic. And whatever you get is your PERT estimate. Now, PERT estimate is P plus 4R plus O divided by 6. PERT estimate is a 3-point estimate. And of course, the reason why we call it a 3-point estimate is because it uses 3 variables, right? Pessimistic, optimistic, and most likely or realistic. So PERT falls under 3-point estimate. PERT is also known as beta distribution. And of course, its formula is P plus 4R plus O all divided by 6, right? But PERT is not the only 3-point estimate. We have what we call triangular distribution. So there's another 3-point estimate that uses exactly the same variable, what is called triangular distribution. And it's given by P, pessimistic estimate, plus optimistic, plus realistic, divided by 3 instead of divided by 6. Now, this is called triangular distribution. And the difference between PERT or beta distribution and triangular distribution is that the PERT is a weighted average. PERT is a weighted average, while triangular distribution is a simple average. So what is weighted in PERT is that the realistic variable comes 4 times. So realistic variable. So that means when you do beta distribution or PERT, the answer is always closer to the realistic estimate, right? So what I want you guys to do is your route to work. I want you to come up with these 3 estimates: pessimistic, realistic, and optimistic, right? I want you to come up with the 3 estimates and find out the PERT estimate, right? Find out the PERT estimate. Yes. PERT estimate, right? Worst case scenario, best case scenario, most likely scenario. So let's do that now. I'll give you 1 minute for PERT, 1 minute for triangular distribution. All right, let's do that now. 1 minute for PERT, 1 minute for triangular distribution. So 2 minutes. So what's your PERT estimate?
Yeah, so my PERT estimate is 45 minutes.
Okay.
And the triangular one is also 45 minutes. So what I did was my pessimistic, it would take me, say, an hour, that's 60 minutes. Realistically, it would take me 45 minutes. If I'm being optimistic, everything, nothing on the road, it's like a weekend, and I have to go to work, it would take me about 30 minutes.
Okay.
So that was what I used, and it gave me the same value.
Fantastic. Which means
both.
You have a perfect estimate. That's what it means.
Oh, okay. For me to get the same value with both?
Yes. It means you have a perfect estimate. Both your pessimistic, your PERT and triangular distribution
and the triangular
are the same. So that means you have a very good estimate. So it doesn't matter which method you use, you get the same answer. Yeah. So that's good. 45 minutes it is. All right. And it doesn't matter if it's different, because usually PERT is what people use over triangular distribution. So so it's good if they both align. That's good.
But usually the PERT is more accurate, right? Because of the weighted.
Yes, weighted average. Yes.
Average.
Yes. Yes. All right. Isaiah, are you done? Are you done?
Yes, I am. But I have one distinct. The other standard is the one I think I want to clarify. So the first one, I still got around, I initially said 30 minutes. So for the PET formula, I got 30 minutes, 8 seconds with
Okay.
my calculations.
Okay.
So, okay, so I said for the P, I used 35. Then the realistic, I use 30. And the other one too, optimistic, I use 30. But now coming to the standard deviation,
No. I don't want you to do standard deviation.
oh, okay. I
Yeah,
don't
I
know.
just asked for PERT and triangular distribution. That's a simple average.
Okay. Okay.
So you got 30.8 seconds
Seconds. Yes.
for PERT. What about your triangular?
Please, a brief thing about triangular. I think I'm mixing it up first.
Triangular is a simple average of your pessimistic, optimistic, and realistic. Just add them up and divide by 3.
Okay. 1695 divided by 3. Okay. Oh, 31 minutes, 6 seconds.
Okay, so they're close.
Yes.
Okay, that's fine. That is fine. Okay, all right. So now we're going to talk about standard deviation later when we get to quality, and variance is the square of standard deviation. We will talk about it in quality. Now, the reason why standard deviation is here is to help us determine the variability between your estimates. So if I say the it's going to take me, let's use the 30 minutes estimate. It's going to take me 30 minutes to get to work. When you calculate standard deviation, you are going to look at the range of estimates that make up, say, 95%, right? So I'll explain this better when we get to quality, right? Under the concept of the normal distribution curve. But in this knowledge, you don't really need to know that standard deviation. But just remember that your worst case and your best case scenarios are what help you to get the standard deviation. So just have that at the back of your mind, and we'll revisit this in another knowledge area. So why did we talk about all the estimating techniques? It's because when you want to estimate the duration of your task, and of course, if you look at the input, you have the list of activities that you're going to start estimating their duration. Some of them you probably use analogous parametric. So what we want to do in this process is to estimate activity durations. So of course, list of activities is an input. Then assumptions we've made, right? Then what we've learned in the past as regarding estimating activities that can help us. Then another key input are the resources that are going to be assigned, like your project team assignments, your resource requirements, right? These also factor resources. And the reason why we have to look at resources is because resources also determine the duration based on the quantity and type of resource you assign. We also have the resource breakdown structure, which shows the different types of resources you're going to be using in your project, and also the resource calendars, which shows the working times of resources on your project. So in other words, in the inputs, we're looking at the activities and the resources, generally speaking. That is what you need to look at. The activities and the resources that are going to be assigned to your project, right? We also have to look at risk if we're going to add some extra time to compensate for risk. And we also have enterprise environmental factors and organization process assets. So expert judgment, an expert can an individual or group that has knowledge in past previous projects or past previous activities can help us to determine the duration of the task. That's using expert judgment. Or we can use analogous and say, okay, we've done this task before. If it took us 1 week, then we're saying, okay, compared to what we did before, this task should take 1 week as well. Or let's say we have a parameter, and the parameter is based on the productivity rate of your resources, right? You can use parametric estimating to estimate the duration of the task. Now, look at 3-point estimating. 3-point estimating is where you come up with 3 estimates, worst case scenario, best case scenario, and most likely. And then you can choose PERT or triangular distribution. That's why you need to know that 3-point estimate is not just PERT, it's also triangular distribution. Then bottom-up estimating, right, is also a technique you can use. And then alternative analysis is where we now look at the different alternative estimates we can generate from the different methods and decide which one we're going to choose, right? Remember, look at when you did 3-point estimating using PERT, that's beta distribution and triangular distribution. When you compare the two, they were close together, right? In fact, Sean's estimate was same. So you can look at other methods of estimating and then come up with the one that you're going to select for that task. Reserve analysis is where we factor risk and add it to the duration of the task, the estimate, duration estimate. So let's say you are in the construction industry and it's the rainy season. Now, during rainy season, construction work is slower because of the slippery surface, right? That may, slow down. When it's slippery, you don't want to start moving very fast because it can be dangerous on a construction. So maybe we find that we're now in the rainy season and we want to estimate the duration of construction activities, especially the ones that take place externally. You might want to factor a couple of extra days for the task. And that's what reserve analysis is there for. The additional days you factor for the sake of risk. Then decision-making techniques can be used, and then meetings. Now, we can, under decision-making techniques, there's something called fist of 5 voting. Now, what do you mean fist of 5 voting? So let's say that it's an agile technique. It's an agile technique, right, borrowed into waterfall. So let's say I feel that an activity should take 2 days. If we're doing fist of 5 voting, and I'm talking to team members who have experience, they will raise their fist, and whatever I see on their hands determines what they think about my estimate. So if I say a task will take 2 days, and let's say that we have 5 people in a meeting, and one of them raises 5 hands, 5 fingers, that person is saying they totally agree with my estimate. They completely agree with my estimate. So if I see maybe out of 5 people, one person raises 5 fingers, it means he totally agrees. Now, if one other person raises 4 fingers, it means they agree, but not to the degree of the 5 fingers, right? So they strongly agree. One is totally agree. The second one with 4 fingers strongly agree. But if I see someone that raises 3 fingers, that one is they just agree, right? So if I see someone that raises 2 fingers up, they have their 2 fingers up, I'm going to say that that person disagrees with my estimate, right? If I see one person that has 1 finger up, they strongly disagree with my estimate. And if I see someone that has a fist up, right, just fist your hand up, they completely disagree with my estimate. So what happens in fist of five voting is after you've done it, you can go and meet, you can ask the people that don't agree with your estimate reasons why they don't agree. And you can also repeat the estimation after hearing from them to see if you get consensus on what you are estimating. That means if after discussion, you can repeat the exercise and see if you get more positive votes. Yeah, sure.
Yes, so this fist of five voting is quite interesting. So does it mean as I've told them what they're going to be doing, or is it like everybody knows? I
Of
was
course.
just curious.
No. So it's a task that maybe you want to work on, and your
Mhm.
team members have experience in that task, and we come up with an estimate, and you're now using fist of five voting to determine whether you should adopt that estimate.
Okay, so am I and I will also be telling the team how to vote, right?
No, well,
They already know.
that's if they don't know. You can teach them,
Okay, okay.
and then try
Because
that.
I've never heard of it.
Yes, that's why I said it's an agile technique.
Oh,
That
it's agile. Yeah, okay.
agile, yeah. So
Okay.
uh, it's not very common.
Okay. I want to ask a question.
Yeah,
So
please go ahead.
this, so if someone raises four
Yeah,
fingers, that means they agree.
they strongly agree. Some like
Strongly.
strongly agree.
Okay. 5 fingers is
Completely agree.
completely. Okay. 3 fingers
They
is
agree.
agree. Oh, okay.
Eh, I think it's called Likert scale.
Okay,
Likert
just like
scale.
when you are feeling on a
Agree,
rate
strongly
scale. Yes, I
agree.
understand.
Yes.
Okay.
Is it Likert? I
I
think
think
it's
it
called.
is.
I think it's called
The rate based on the highest to the
yeah,
highest to the smallest.
Likert scale. I think this is the name, but I'm sure you know that scale that says
Yes.
agree, disagree,
Okay.
strong. Yeah, that's it.
So the one finger is this totally disagree.
No, one finger is strongly disagree.
Strongly
A
disagree.
fist, a fist, that fist. You
Mm-hmm.
show a fist like um you want to strike. Power to the people, that kind of fist.
Okay.
You completely disagree.
Okay.
Yeah.
Okay. Thank you.
Welcome. So whatever technique or method you use, what we expect is that you must have duration estimates. Then we should also have basis of estimates. So when we talk about basis of estimates, what are we talking about? We're talking about the method. So for every duration estimate you have in your project, and what are duration estimates? Duration estimates of your activities. That means after this process, all your activities must have duration because you use several methods to estimate it. So for some, you might use analogous. For some, you might use parametric. For some, you might use product. And for some, you may look at the alternatives and select, right? So whatever method you use, what we're saying is at the end of this process, all the activities in your project must have their duration estimate. That's the first one. Secondly, we must have basis of estimate. So basis of estimate is created to help people understand how we came about the estimate. So it's my basis of estimate can state the method that was used or technique that was used in estimating, the assumptions we considered, the risk factors that we looked at, and the range of possible estimates, right? And sometimes the confidence level. So that means that if I see an estimate, let's say, remember the tiling example, that a tiler can lay 5 square meters of tiles in 2 hours, and we have 100 square meters of tiles of space to lay. If I estimate 40 hours for that task, in my basis of estimate, I will state the method, I'll state the parameters, so that anybody that sees 40 hours can understand how I arrive. So for every estimate you make in your project, it should follow, you should have a supporting document called the basis of estimate, and that explains the rationale on how we developed those estimates. So we're going to talk about, we're getting to the end of the knowledge area and how to develop a schedule. Now, let's go back to the beginning to see where we are in the roadmap. And developing your schedule is one of the last things that ties everything we've been doing together. So look at it. This is where all the arrows fit in. That means to develop the schedule, we first of all must have a schedule management plan. We have to define activities. We have to sequence activities and create a network diagram. We have to determine the duration of those activities. Somewhere along the line, we also have to estimate the resources that will be assigned to those tasks. Remember what I said about this process is not done in the schedule knowledge area, is now done in the resource knowledge area, but it is done before we do activity duration estimation, because the quantity of the resources and types of resources assigned per activity will influence the duration of the activities. Okay, so this is the moment we've been waiting for. That's all I'm trying to say. This is actually why we started talking about schedule management, because this is where we put all the outputs of the different processes we've talked about together, and then we form the schedule. Remember the elements that make up the schedule. We need the activities. Where did we get the activities from? We got activities from the define activities process, right? We need the duration. Where did we get duration from? Where we need resources. So you can see that. And then we need the arrangement. That's the network diagram, which shows the arrangement. And when you put all these factors together, you can actually piece a schedule. And that's why develop schedule process is very, very important, because it actually brings all our work together, and then we can now form a schedule. So that's why you're going to see that the inputs of this process are the outputs of other processes we've done. For example, the schedule management plan is the output of plan schedule management. We have the activity list and activity attributes, which are the output of defined activities. We have the duration estimates and their basis of estimates, which is the output of estimate activity duration. And then you also have resources assigned, your project team, the resource requirements and resource calendars, which, so that means that we're putting together several things. And then the network diagram, which shows the logical arrangement of activities from the start of the project to the end. So more or less, the schedule is a combination of all these things put together to form a schedule. So let's look at tools and techniques. Number one, schedule network analysis. Now, schedule network analysis simply means analyzing the network diagram. Remember, the schedule network diagram is one of the inputs. So schedule network analysis is anything that you do that analyzes network diagram. And there are two other techniques that involve you analyzing the network diagram, which is the critical path method, which we're going to talk about, and resource optimization. In other words, critical path method and resource optimization require you to analyze the network diagram. In other words, critical path method and resource optimization are subsets of the schedule network analysis. They are subsets of the schedule network analysis. Okay. They are subsets of the schedule network analysis. Then we have the what if scenario analysis. And this is where we talk about coming up with multiple scenarios, right? Multiple scenarios of that can help us determine how long the project will take. So we can say, okay, if this happens, that happens on a project, this is when we're likely going to finish the project. And then simulation is where you come up with something like Monte Carlo to predict how long the project will take, right? Then we've talked about leads and lags. And when you're developing a schedule, you can adjust leads and lags. Leads, you can adjust leads by increasing the overlap to save time and shortening your lags to save time. Another thing that we can do here is to do what we call schedule compression. Schedule compression involves two techniques, crashing and fast tracking, right? So when we talk about schedule compression, crashing and fast tracking are techniques that helps us to shorten our schedule. Then project management information system. Now, let me say more about schedule compression. The idea of schedule compression is to reduce the duration of your project. So let's say that our schedule is going to take longer than what the sponsor expects. What we need to do is to consider ways to crash or fast track the project. That's why it's here. Project management information systems simply mean the software you're going to use to schedule, right? Information systems, softwares are categorized under information system. So your scheduling tool, scheduling software that you're going to use. And if your project is agile, then agile release planning is how you're going to determine. So agile release planning is what we're going to do. Okay. So that is that, that is that, that is that, that is that. So so many things, many techniques, and we're going to look at them. Now, let me tell you something you will notice about my pattern of teaching. If you haven't noticed, there's something I do. I focus more on tools and techniques than on input and outputs, right? Why? Because the tools and techniques are the real deal. They are the things that actually create the outputs that you want. The tools and techniques transform the information or input you have into the output you want. So in any process, I spend the most time explaining tools and techniques. Because if you have the inputs and you don't understand the tools and techniques, there's no way you're going to get the output. So we're going to spend time talking about what critical path method is, resource optimization. We've talked about leads and lags. We talk about schedule compression. And when we go into Agile, we'll talk about Agile release planning. For now, I won't talk about it so that we focus on all the waterfall tools and techniques, even though it's stated here. So at the end of the day, what do we have after using all these techniques? We should have what we call the schedule baseline and the project schedule. And the interesting thing is that these two are the same thing. They are the same thing. They are the same thing when you finish planning your schedule. The project schedule and the schedule baseline are. So the schedule baseline is a copy of your project schedule and serves as a reference so that when your project schedule starts changing, you can compare it with the schedule baseline. So if I schedule a project now, I will baseline it so that I have the exact replica as a reference so that when changes happen, I can look at the reference and say, oh, I've deviated. So the schedule baseline is a copy of your project schedule. At the end of planning, they're the same, but when you go into executing, they may differ based on the variance in your schedule. Then schedule data is the data you can draw up from your schedule. So the start date of your task, the finish date, the resources, we can draw that data. Now let's talk about project calendars, and I think this is the last thing I'll talk about. The output. I'm just focusing on the key outputs. Now, when it comes to project calendar, there are different calendars for your project. Different calendars for your project, right? Different calendars for your project. So let me talk about calendars, right? So one of the calendars is the default calendar, which is anything from 8 a.m. to 5 p.m., right? 8 a.m. to 5 p.m. Normal working hours for everybody, right? 9 hours work, right? So we can also have a night calendar. Night calendar should be anything from 8 p.m. to 5 a.m. Then you can have a project calendar of even 24/7. I've even seen a project calendar of 24/6, which means they work for 24 hours for 6 days and take 1 day break. So project calendars mean that you now determine the calendar for the project, and sometimes you can even have a unique calendar for scheduling. Now, I'm going to give you a strong recommendation, right? When you can, after this PMP course, please do a scheduling course. Like Microsoft Project is good, and we also offer that, right? So that you can really understand what I'm saying. So before we wrap up, I'm going to show you the difference between a schedule baseline and project schedule using Microsoft Project. And let me do that. I think I just have 3 minutes. I think that's enough time for me, right, to do so. Right. My goal is for you to love project management as I love it. So anything that will help you do that is what I'm going to do. So this is Microsoft project. Please confirm you see something that looks like Excel on your screen.
Yeah.
All right, fantastic. Fisayo, do you see that?
Yeah, I do.
Okay, so this is a typical, what we call a Gantt chart, right? Now, what happens is that you and your team are going to sit down and plan the task. Of course, each of these are tasks in a construction project, setting out, excavation, their task, and your team and other planners will come together and estimate duration and determine the relationship between tasks. So this is where they start to start, finish to start. When you come to scheduling, all those predecessor types, you are going to use them. So it's not just for exam, those that schedule. And you can actually get a lucrative job as a scheduler. There, I have someone who I trained, is now a project manager, and is done some very interesting jobs in Canada. One of the jobs he had is in Primavera, which is scheduling, and now is now scheduling using Microsoft Project, right? And I trained him in most of the courses. Primavera, I don't know how much he was earning, and I don't think it was appropriate to ask. But if you get a scheduling job, Primavera in the US, you get paid 50 hours, $50 per hour. There are some nice jobs when it comes to scheduling, and scheduling is very interesting. So let me just show you what I want to show you without taking more of your time. So I've scheduled all my activities, and this is what it looks like. And my project duration is what? 147 days. Now, if the client is happy with this and your management is happy, the next thing you should do is you're going to baseline the project. So there are just some simple, I'm just going to show you simply how to baseline a project. So I'm going to set baseline here and baseline the entire project, and that's it. I baseline the project, right? Now, if I want to see what my baseline, what the baseline I set, if I want to see the baseline, all I have to do is come to, that's my format. Okay, so click on format and go to my baseline and click the save baseline. Now, immediately when I clicked baseline, you notice a change. I'm going to undo. Let me go back so that you can see the difference. Now, notice when I didn't set my baseline, everything was all blue. But let me redo. When I set the baseline, there's a gray bar under the blue bar. The gray bar is the baseline I just set. Now, remember, the baseline is a reference. It's not your schedule. It's actually a copy of your schedule. And that's why they are the same, because it's a copy of your schedule. And it's exactly the same for every task you have. So here, that's what I meant, that the schedule baseline and project schedule are the same when you finish planning. Because once I've created the project schedule, if it's accepted by management and sponsor, you baseline it, which I've done. And so you can see they are exactly the same thing. So what now happens is that when I go into project execution, the actual completion date of the project will now be updated. So let me give an example. So let's say I come to reinforcement works, and reinforcement works took longer than planned. So let's say it took 2 extra days and it became 16 days. Now, I've not entered it. I'm going to enter it. But as I enter 16 days, I've not entered it. I've just increased it. Look at what happens to this part. So I'm going to press enter now. I'm pressing enter now. look at what happened to the project schedule and the schedule baseline. Now, what this is showing me is that according to my original plan, which is the baseline, I've deviated by 2 days. So the project manager now has to see how he can correct this. That's why the baseline is there. So I'm now trying to figure out, can I correct this variance? So I've lost 2 days. What do I have to do? I have to gain 2 days somewhere else. So I'm looking at this and I'm saying, okay, let me see if I can gain 2 days in this task. This task that is 5 days. Let me put more resources here. And when I put more resources here, I can actually reduce the duration to 3 days. If, let's say you have 3 people assigned to this task, then you double the number of people to 6. Maybe they help you save 2 extra days. Look at what has happened. I've gotten back to the baseline. Do you see? The moment I saved 2 extra days, I've gotten back on the baselines. Do you see? Do you guys notice?
Yes, yes.
Yes. So this is why you
Yeah.
need, okay, great. This is why you need a baseline. Because if you don't have a baseline, you're just going to be making changes to your schedule blindly without knowing what you originally planned. So that is why we have 2 outputs. First of all, create your project schedule, then baseline it. Then when you execute, anytime there are deviations, you know what the original plan was, and you can make the necessary changes to get back on the baseline. And I'm going to also reference this tomorrow. I hope we can do this, complete this tomorrow, where we talk about how to control your schedule, because that's exactly what I've done. I've controlled the schedule by making the necessary changes to get back to my baseline. So I do apologize.